Okay, thanks for coming. This is not a talk about an empirical study, but it's rather I'm going to propose a theoretical framework, which we call core perception, where I'm going to propose a reframing of the nature of core knowledge. So we know that even very young pre-verbal infants have a really rich set of representations about the physical and the social world. And I think speaking to this crowd, I don't need to go further about introducing core knowledge. So I'll just say that sometimes as scientists, maybe this work is so foundational that we forget how impressive and how important core knowledge is. It's really, this whole line of research has been asking some of the biggest questions in cognitive science. So what is the earliest representations we have, and what is the initial state of the human mind? But I think there's another question that is also very important, which is what is the nature of these initial representations? Specifically, is core knowledge perceptual or cognitive in nature? This perception and cognition divide is one of the most well-established accounts of the architecture of the human mind. And these are really different kinds of processes. So it's very important to be able to position core knowledge on one side or the other. So is core knowledge more like the way we process motion and depth and orientation and color and so on, which is perceptual? Or is it more like the way we think about the way we process information about the stock market or the history of the Roman Empire and so on? The common assumption about core knowledge is that it is cognitive in nature. Here's Spelke's view in the 80s. She said objects are conceived as opposed to perceived. Humans come to know about an object's unity, boundaries, and persistence in ways like those by which we come to know about its market material composition or its market value. Notice also the year of this quote. It's really at the early times of core knowledge research, and scholars have been asking this question even until today. I should also say that Spelke has revised her own view. In her recent book, one of the central theses is that core knowledge is neither perceptual nor cognitive. I won't show you more quotes, but I just wanted to point out that this assumption that core knowledge is cognitive or at least non-perceptual is even evident in the very name of this conference we're in. It's called a conference on cognitive development, right? No one is saying this is perceptual development. But this is what I'm gonna challenge here. I'm gonna propose that core knowledge is perceptual in nature, in a view that my co-authors and I call core perception. What motivated our view is a striking overlap we found between infants' core knowledge and adults' visual perception. That is, you can take virtually any representation in infants, pre-verbal infants, and you will find strikingly the same representation in adults' visual perception as demonstrated by recent discoveries in vision science. And this suggests that we're probably looking at the same thing. Before I go into a demonstration, first, how do we know if a process is perceptual or not? We use a set of behavioral signatures following the tradition from many other scholars. And I will use depth perception as an example here. So perceptual processes are typically fast, happening within 200 milliseconds, whereas cognitive processes are typically slower. Perceptual processes are usually automatic. So if you open your eyes, you just spontaneously process the colors and orientations and depth in your visual scene, whereas cognitive processes tend to be optional. Perceptual processes are sensitive to perceptual input. So the way, for example, you compute binocular depth is through the tiny differences from your two eyes images. And if you change that by a tiny bit, you can completely destroy the impression of depth. Cognitive processes are less sensitive to perceptual input. Encapsulation or irresistibility, perceptual processes are not influenced by higher level beliefs or knowledge. This is canonically demonstrated with illusions like this. You see the top line as longer than the bottom line, but actually they're of the same length. But even if you know that they're of the same length, you still cannot help but see the top one as longer than the bottom one. And the flip side of this is that perception influences other perceptual processes. And this illusion itself is a demonstration. So your perspectival cue to depth is influencing how you perceive the length of the lines. Perceptual processes exhibit most or all of these signatures, whereas cognitive processes exhibit few or none of them. And now I'm gonna show you one study where a core knowledge representation is properly embedded in a perceptual process. So this is from my own work called the double ring illusion. And this effect is so strong that actually now you can experience this itself as an illusion. So if you look at the fixation cross, how do the rings appear to move? If you give it a second, maybe it alternates, right? Sometimes it moves in 180 rotations, flipping back and forth, sometimes in 360 rotations, continuously towards the same direction. That is normal because you are not given enough visual information to tell how the rings are moving. You are given information that's intrinsically impoverished. So you alternate between different interpretations. And how about here? If you're like most people, now you see this as primarily moving only in 180 motions, flipping back and forth. But you're actually looking at the same rings as before, but this 360 interpretation is really hard to see, right? The rationale is that 360 co-rotations would require the rings to pass through each other. And it appears that our visual system just really doesn't like that. So it forces you to see this alternative. So this suggests that we have this representation of solidity, which is objects cannot pass through each other, that guides our processing of motion. Here is another case. So now I'm removing any possibility of collision, and for most people, this unstable percept is back, right? You alternate between 360 and 180 again. So this suggests that when you are not given enough visual information, your visual system makes use of this solidity constraint to process object motion. But what about those signatures? So we designed an experiment to target them. So the rationale is that if the rings bounce back, then that should happen slightly before this frame, where they're on the frontal parallel plane. Because of the 3D volume of the ring, they should bounce back at a slight angle, right? So we then hypothesized that you might then underestimate the maximum width of one of the rings. Whereas if you are seeing the rings as moving in 360 motion, you should not find this underestimation effect. And you can kind of see this here, even just with the demo. The way I experience this is I never really see the rings reaching their full width. So it seems that our visual system just really doesn't like those frames where the rings are passing through each other. The key to note here is that I'm not asking subjects about physics or about solidity, right? I'm asking something completely orthogonal to that. I'm asking the simple question of what is the width of those rings. So if we find an effect, that means that people are automatically making use of the solidity constraint, even when task irrelevant. And that is exactly what we found. People consistently underestimated the width of one of the overlapping rings, but that's not, and it's less so when the rings are separated. So that demonstrates automaticity, as I just explained, and influence on other perceptual processes, because solidity is influencing on how you see motion and how you see width. I won't have time to expand on all the empirical evidence, but so this is solidity in, wait, let me find my, this is the solidity in the adult visual system, and a bunch of other vision work has shown other physical representations that include cohesion, topology, spatiotemporal continuity, and causality. And this list might start to look familiar because these are the very same representation that underlie infants' core knowledge. And this overlap actually applies not only to what infants and adults do, but this also applies to limits of their representations and errors they make. So width versus height in containment, that means if you're looking at a container and if you lower an object into the container, you prioritize the width information of that object over the height information of that object. And this is true both in adult vision and in infant development. Features are less prioritized than spatiotemporal continuity for object individuation. And rigidity, we don't care much about rigidity to individuate objects. And I'm listing only one study here, but there are actually more. And this overlap between infants' core knowledge and adults' vision applies way beyond physics. Actually, it applies to all domains of core knowledge, from geometry to numbers to the social world. And this is based on more than 160 studies I reviewed from both sides. And so this can't be a coincidence, right? It's too consistent to be a coincidence. So this suggests that we are probably studying the same thing. And before I conclude, I just want to address some of the common misconceptions about perception. These are actually the reasons why many scholars rejected the idea that core knowledge may be part of perception. So first, vision cannot operate over the unseen. The intuition goes, if we are not even receiving retinal input, how can that be about seeing? This is particularly important for core knowledge research because a lot of studies involve occluding objects. But vision can also infer missing information. So the first example is the optic disc. So on your retina, there's a big hole where there is no photoreceptor. But you don't experience a big hole on your visual field, right? So our visual system is able to infer information based on the neighboring information. Another one is blinking. These are momentary. These are moments where you receive no visual input, but you don't experience disruptions of your in the way we experience the world. Another one is perceptual processes cannot be cross-modal. So some studies show that infants can match the number of sounds they hear to the number of objects they see. So the intuition goes, mustn't they be processing those sources of information in a central cognitive space? But this doesn't have to be the case. And I think this is fairly intuitive to the point that we don't really even need a study. So let's say I tap on this table, and I can sense this in my hand via the tactile modality. I can hear it, and I can see it. So now I have three modalities that I need to organize. And this has to happen really at a millisecond precision, right? And this kind of processing really happens at every single moment in our lives. When we walk around, we feel our feet on the floor, we see our feet, and we hear our footstep. when we talk to someone, we see their lips move, and we also hear their sound. So we have to, at all these moments, we have to match information from different modalities. And having a central cognitive system do this work just seems so suboptimal. You would want a low-level, more basic, automatic, encapsulated system, right? Okay, and to conclude, perception is far more sophisticated than commonly thought, as demonstrated by recent development in vision science, such that physics, objects, agents, and so on can be processed in similar ways as color, motion, depth, and so on. And we find a strikingly consistent, we found strikingly similar performance and errors in adult vision and in infants' core knowledge, which suggests that we should probably revise the nature of core knowledge, and we propose that this is part of perception itself. And just before I go, I want to raise a corollary that from our framework. So adults obviously can reason about physics, right? If I ask you, can objects pass through each other? Obviously, no, they can't. But if the initial representation of, say, solidity is perceptual, then there is probably a mechanism that transfers that initial perceptual representation to the cognitive system at some point, right? So a kind of a copy-pasting process. What is that process? I don't know. I think it is an interesting open question that is raised by this framework, and I think future work can look into this. And last, we published this paper recently on BBS as a target article. Unfortunately, the call for commentaries is already closed, but I'll be hanging around so you can attack me in person here. I want to thank my amazing co-authors, Alon, Hafri, Véronique, Izard, Chaz, Firestone, and Brent, Strickland. And that's it. Thank you.